Alrighty, welcome my algebra students. Today we are talking about solving equations with variables on both sides. So I can solve equations with variables on both sides, and I can determine whether equations have no solution or infinitely many solutions. So when we get to problems like this, means I'm going to have maybe an x, a 3x on this side, a 2x on this side. And so how do I solve it when there's variables on both sides? What ends up happening is that we end up getting things where we can have a solution. We could have no solution, but we could also have infinitely many solutions. And so let's go ahead and take a look at some things here. Keep following along with me, but feel free to pause whenever you need to. Alrighty, so how can you solve an equation that has variables on both sides? So again, this is kind of talking about where it really depends on what's going on in your operation, and solving them out, which is the biggest part, and what we really want to do is combine those x terms. So whether that's where, subtracting over the x or adding the x or adding whatever variable it is or subtracting whatever variable it is, we want to get those together and still solve for x if we can, or that variable. So here is what we have. Solving equations with variables on both sides. To solve equations with variables on both sides, collect the variable term on one side and the constant terms on the other. Remember, your constant terms are going to be anything that don't have a variable with it. So, maybe it says something like 2x plus 5. Well, that 5 is a constant term. It has no variable with it. It is considered the constant. So in here it says some equations do not have one solution. Equations can also have no solution or infinitely many solutions. So, let's make it even more complicated. You can either have an answer, a no solution, or infinitely many. When solving an equation that has no solution, you will obtain an equivalent equation that is not true for any value of the variable. So if it becomes a no solution, you're going to get something like 0 equals 2. Well, does 0 ever equal 2? No. And so that's going to be a no solution. In the case that you get an infinitely many solution, it's going to have something that is a true statement. So, 2 equals 2. Oh yeah, that does work. So that means I could have any possibility of x or, whatever that variable is. I could have any possibility of number and it would work there. So that's why I can't just say, oh, 2 works, but 2 does work, but also 3 works. So instead, I would say infinitely many solutions. And take a look at some examples of that, okay? So here is the first problem where we've got variables on both sides. In this case, we do have a variable of x, and we want to get those x's to be together. So my first thing is looking here, it just says solve, and they want us to check the solution. My first thing on any algebraic problem is I always start by rewriting this. Write it in your own terms. That way you can show out all your work and you're not confined into this little part where they wrote it down. So I just start rewriting it. I'm not changing anything yet. Once I start looking at this, I notice that typically we like our, variables on this side, but I'm not going to keep the variable on this side. To me, the easiest way to move over this x is to take this 2x and add it over here. That only gives me one step and I combine. If I was to move this 7x over, I would have to make sure that I know that this there's still going to be like a 0 over here. So I'm just going to add the 2x. If you really wanted to, you could move that 7x over. You're still going to get the same answer as long as you make sure you understand that this is there would be like an imaginary plus 0 over here. So I'm going to add plus 2x. These cancel out. I'm left with 15 equals, well, if I take a negative 7 plus a positive 2, remember we're just worrying about the coefficients because it's still going to stay x. This is going to end up being a negative 5x. All right, well, to undo my multiplication, I divide. Why did I say subtract? So we're going to divide each side by negative 5. With that being said, I get x and equals, well, 15 divided by negative 5 gives me a negative 3. And you can always just flip it around again if you need to, if that works better for you. It doesn't matter which form it's, you know, in, if the x or the -3 come first, as long as we still have that equal part in there. Alrighty? Let's keep moving forward. And some of these I'm going to have to kind of change directions on from these slides, and there was extra writing down here from previous. Go ahead and solve out this problem. And what I'm noticing about this problem, before I even start writing it out, I know that my first step is going to be distributing out these numbers. And so I think as I start solving this out, I'm just going to do that first. That's going to be my first step before I rewrite it out. So I'm going to distribute this -2 to the x. So I'd have -2x, not to the power of x, I'm just multiplying them through. And then I would have a subtraction, but realize that I could also think of this as a -5, so -5 times -2, which would be a +10, so I'd really end up adding 10. So if I go to this side, 6 times 2 is 12. Again, this would be like a -1/2. Well, 6 times a -1/2, that would end up giving me 3, or -3x. All right, I want to get my x's together. To me, I think it'd be easy to move this 3x. So I'm going to start by putting the x's together. I like to have my line down the center. And I'm just going to undo this subtraction operation by adding it. They're like terms, so I want to add those together. A -2x plus a +3x actually just leaves me with just x, or you can think of it as 1x, but it's the same as just x. Plus 10 equals 12. Alrighty, I want to move over this 10 so that the x is by itself. So I'm going to subtract 10. And remember, this 1x just means x, so I'm left with x equals, and then 12 minus 10 is 2. And so right now, all the ones we've looked at so far are one solution operations. And so sometimes you might see things where, does it have one solution? Does it have no solutions? Does it have infinitely? So you might want to write, you know, in this case, it's one solution. If you do want that though, if you think there's one solution or you have one solution, you still need to tell me what is that solution. So I'm still going to be looking for x equals 2. You can't just say one solution. I still want to know what is that answer then. We're just going to keep going. Let's take a look at example 3, okay? So this is where we're going to run into either maybe a no solution or an infinitely many solutions. So let's go ahead by doing the first step that I do and rewriting it out. I am not going to do anything to change this equation yet. I'm just going to kind of set it up and start analyzing it. One thing I noticed is I have a -4x on each side, which is already a big clue on if it has one solution, no solution, and infinitely. And we'll talk about that more once we figure out what this one is. And so I think, I don't know, I could move this, either one of these 4x's over, but let's move it over this way. So this one's a minus, so we're going to add the 4x. Again, it doesn't matter which side, as long as you're following the inverse operations. So in this case, I have 3 equals -7. And then notice, look, a -4x and a +4x, don't those cancel out? So then, does 3 equal -7? No! So this is also when we were looking back here. When solutions of equation has no solution, you obtain an equivalent equation that is not true for any one of the variables. So 3 does not equal -7. So in this case, there's going to be a no solution. There's no number in the universe that's going to work to make this problem correct. And so, no solution. Let's take a look at another one. Maybe this time we'll run into a infinitely many. So I'm going to start by rewriting it out because I want to solve. And I'm going to start by distributing while I do this. So this 6x plus 4 is still going to say 6x plus 4 equals then. And then I want to do 3/2 times 4. So I could write it out. Because remember, 4 out of 1 is the same as 4. So that gave me 12 out of 2, which is also a 6x. Okay. 6x. And then a 4 times a 1 plus 4. What do you notice about this equation? Stop and answer the question. What I notice about this equation is that they're the same exact equation. So if I really actually wanted to solve these, wouldn't any number for x work? I could put 2 in here. Okay, 6 times 2 is 12. 12 plus 4 is 16. It's still going to make the same thing on this side. In theory, I could solve this out and subtract 6x to each side. They cancel each other out, and I get 4 equals 4. 4 does equal 4.
If you're in the building, could you please call the office? Ms. Thorne, please call the office.
Great for interruptions. 4 does equal 4, so you get infinitely many. Infinitely many. Okay, so that would be your solution. Any solution would work. Anything for x. I'm just checking if there was some other problems on here. That's from something else. Alrighty, just for the sake of these, we're not going to worry about these ones at the bottom here. All right, your last 2 problems to note to check you for your understanding here on this video are these 2. I just want you to do these 2 problems. Put your answer in the sidebar over, and we will discuss more while we're in class. But take the time to try and see if you can get if these are a 1 solution, a no solution, or an infinitely many. And then also if it's a 1 solution, please put in the what is the 1 solution. Alrighty? Let me know if you got any questions, but I will see you guys next time.